Dandenong Ranges National Park lies just 35 kilometers from Melbourne, yet it feels like another world. Towering mountain ash trees pierce the skyline, and deep gullies hum with fern life. But look closer and you'll see the vegetation here is anything but static. This landscape is a living system, a place where plant communities are constantly shifting, driven by both natural and human forces. This video explores vegetation dynamics, the idea that plant communities change over time and space due to ecological processes like disturbance, competition, and succession. In the Dandenong Ranges, we see these dynamics unfold across a gradient, from wet sclerophyll forests dominated by mountain ash trees to cool temperate rainforest patches and drier open woodlands in the northern slopes. These communities don't stay fixed, they transition, they respond to fire, to climate, and human intervention. Understanding how and why these shifts occur is key to protecting this place. One striking example of vegetation transition here involves the mountain ash forest. Historically, these forests regenerated after low-frequency, high-intensity fires, creating even-aged stands. But with increased fire frequency and the legacy of logging, we're seeing interruptions in that cycle. If fires recur before trees reach reproductive maturity, typically 20 years, seed banks are lost and the community begins to shift. Research by Lyndon Mayer et al. Warns of regeneration failure and transitions to shrub-dominated systems with wattle and tea trees replacing the canopy species. These transitions are not theoretical, they're visible in the park's disturbed areas. Understory transitions are also evident. In the wetter gullies, shade-tolerant ferns like Dicksonia antarctica and Belknap wattsi dominate, facilitating moisture retention and buffering microclimates. But when tree cover is lost or edge effects from roads intensify, these understory species retreat, replaced by generalists or invasive exotics. Co-occurrence patterns also tell a story. Along transitional zones between wet and dry forests, species like Eucalyptus obliqua and Acacia melanoxylon overlap, competing for light and space. In these edges, facilitation and competition coexist. Tree ferns may shelter seedlings, but dense regrowth of fast-growing shrubs can crowd them out. This shows how vegetation transitions are shaped not just by external disturbance, but by interactions within the community itself. Invasive species, such as blackberry and ivy, further disrupt these dynamics. They alter soil composition, outcompete native seedlings, and arrest succession, freezing plant communities in early or degraded states. Reflecting on these changes has reshaped how I see forest resilience. I used to view vegetation as static, something to preserve in its ideal form. But now I see it as more fluid and responsive, shaped by a complex mix of biological and human forces. In the Dandenong Ranges, protecting biodiversity means managing vegetation transitions, not resisting them. For example, we could support the natural succession through targeted weed removal. We can use this prescribed burns informed by species regeneration timelines, and we can monitor edge effects and microclimate shifts that drive the community turnover. This understanding of vegetation dynamics also affirms the need for landscape scale thinking. Changes in one plant community ripple into others, affecting pollinators, seed dispersers, and fire behavior. So the Dandenong Ranges are not just a beautiful backdrop. They're a dynamic ecological system. By studying how plant communities shift and what drives those changes, we can better support the resilience of the forests into the future.